Hello, today we're going to be talking about the periodic table again in the last two large sections of the periodic table, which is the nonmetals and the metalloids. Remember, when we classify elements, the elements are classified into three regions. They're the metals, the nonmetals, and the metalloids. Remember, the metalloids are the elements that do not conduct heat and electricity well, and the metalloids semiconductors are the ones that can somewhat conduct heat and electricity. They're kind of in that middle area. So those are the two ones that we're going to be talking about today. Nonmetals, remember, do not conduct heat or electricity, and they're found on the far right side of the periodic table to the right of that stair step. Many of them are gases, and they can be broken down into different categories. We have the halogens, the noble gases. Remember, helium, even though it's all the way over on the left-hand side in the first group, is actually part of the nonmetals on the right-hand side, these yellow ones that are over here. And you'll notice that the elements of the human body, a vast majority of them, except for calcium, are all nonmetals. Okay. First family group we're going to talk about is the halogens, group 17. These are a pretty interesting group because they are very reactive. They have 7 valence electrons, which means they are just one short of a full shell, and they like to take that one. They will rip it very energetically from any other element that it can get it, and because they only need that one, that's why they're very reactive, especially with the alkali metals, the group that is in group 1, because the alkali metals have that one electron to give. All right, and they are part of that one is chlorine, bromine, iodine. And chlorine is a very can be toxic. It's so energetic it will literally, if you have too much chlorine in the air, it can actually suck the oxygen stuff right out of your lungs, the liquid and stuff out of your lungs, which is why they use it in a military. Used to before the Geneva Convention outlawed the effect of gases in the battlefield. Side note, sorry. Commonly, they combine with alkali metals such as sodium and potassium. Here's an example of what it looks like in the gas form, and then iodine, and as well as iodine being poured out into a cup right there. The next group, the last of the families, is called the noble gases. They're the last column in the periodic table. And the reason they're called the noble gases is because they basically don't want to share anything with any other family. And so they're like the nobles of the medieval times, where if you weren't another noble, they wouldn't hang out with you, it had nothing to do with you. So each element of this family has a full outer shell, and that's why they don't want to react. And again, they're called noble because they don't like to mix. They are used in a lot of the neon signs. Notice that neon is the second in the group. It's element number 10. Okay. And one of the reasons why that they're so important and it took so long to find them is because they're inert. And that basically means they won't react to anything, which is why you put helium in balloons, not hydrogen. Because if you put hydrogen in all the balloons, party balloons, stuff like that, a little bit of flame from a candle would cause those things to go boom. But helium doesn't want to do anything to anyone. All right. The metalloids, the semiconductor, is the smallest section of the periodic table elements, and it is that elements that round that stair step right there off to the right-hand side. And they're called semiconductors because they somewhat conduct heat and electricity. The semiconductors, metalloids, separate the metals and the nonmetals on the periodic table on both sides of that stair step. They are boron, silicon, germanium, arsenic, antimony, and tellurium. Silicon probably is the most familiar to you guys because it's used in computer chips. And it is a semiconductive, which allows it to do the 1 and 0 back and forth to off and on that old computers used to use. Many of them others are used to create increased metal hardness. You add a little bit of germanium or boron, and you really increase the strength of the steel that you're dealing with. Here's some extra info. It's just nice to know. Allotropes, there are different forms of the same element. There are 3 allotropes of carbon: graphite, diamond, and buckyballs. A lot of people don't really know that diamonds are actually just made of carbon. That's all they are. It's just the structure of the carbon in a lattice kind of crystalline form that gives the diamond its structure. It's the same element as the graphite that's in your pencils. But that element is arranged in sheets. So the carbon rings are in sheets and they lay on stacked on top of each other, which is why sometimes it's really easy to break your pencil lead if you push sideways on it. And the last allotrope is a buckyball, which is basically manufactured by human, and we're using those in like nanotechnology. And again, we're using them to make nanotubes, basically small, tiny structures, and it takes 10,000 of them. So you think about 10,000 buckyballs lined up, and that's the width of one of your hairs. So it's very, very small. And they're basically using this nanotechnology to use in computers and also to strengthen building materials to make them very, very strong. There are two allotropes of silicon. There's amorphous and crystalline silicon. So there's a silicone that's like the gel, that is used in surgical implants. And then there's also the crystalline form of silicon, which is used in a lot of costume jewelry and things of that nature. Very cheap, easy to manufacture. Synthetic elements and radioactive elements. These are used in smoke detectors, medicine, and some can be used to treat cancer. A lot of the times when you take a radiation therapy, it is some of the different elements that have those radioactive properties that they're using. Smoke detectors are very common new ones, basically use a radioactive, slightly radioactive element that's really safe to us, but that can be used. Basically, they shoot a beam through it and it can detect any particles in the air. And it can differentiate between smoke or fog or water vapor, whereas the old smoke detectors couldn't do that. And there we finished talking about the nonmetals and the metalloids.